Hey guys, so we're going to get a little introduction to section 1.6 with this video. And just a quick review, I want to talk about the measures of center. So this came up earlier in the chapter. We have three measures of center. We have the mean, or the average. We have the median, the middle number, and the mode, which is your most frequent number. Okay, and they're called measures of center because they give us an idea about the middle of the data. You know, sometimes they give us a very good picture of the middle of the data, and sometimes they don't. And it really depends on, you know, each particular data set, if there's outliers and so forth. So let's look at these two dot plots here, and these two dot plots represent the heights in inches of two different basketball teams. Okay, the Dolphins and, yes, the Sweet Peppers. So each dot represents a player's height. So for instance, on the Dolphins, there's a person that's 70 inches. There's two people that are 71 inches, so on and so forth. So we're going to start, I want to find the mean and the median for both teams, and I already have this data plugged into the calculator. So in L1 here, I have the Dolphins' heights, and then in the L2, I have the Sweet Peppers. So I'll just have the calculator find me the average of L1, which would be for the Dolphins. So I do that. We've got an average of 75 and a median, scroll down here, of 74.5. So when you see the average and the median so close together, sometimes that indicates that the data is, you know, either a uniform distribution or a bell-shaped distribution. I don't know that we could say that in this case, but that's sometimes an indication that we look for. If I redo this, but tell the calculator to instead look at the data in L2, that's where the other team is, we've got the Sweet Peppers, which is a great team name. We have an average of, again, 75 and a median of 75. So that's, you know, right on the money there. And if you look at this, I would say that that dot plot sort of is like a bell-shaped curve. Not a perfect one, but, you know, it makes a lot of sense that the average and the median are the same. But when you compare these two teams, you know, against each other, they both have this average height of 75. You know, if you were the coach of the Dolphins and then the coach of the Sweet Peppers, you would think, oh, our teams are pretty much the same. We both have the same average height. But you can see on the dot plot that that's actually not true at all. Okay, so measures of center are great, right? They give us a good idea of the middle, but sometimes we need an even more detailed analysis of what's happening. And this is when we want to look at the measures of variation. Okay. So for the measures of variation, you can see there's going to be three of them, two of which you already know. See, the thing with measures of variation is they indicate how spread out the data is. Okay. So the first one, the most basic measure of variation, is the range. Now, in this scenario above, if you look at these heights, both teams have a range from 70 to 80. They both have a range of 10. So if you only look at the range, it's not really, you know, giving you a more detailed analysis of the heights of that team. But it's a good start. You know, if one team had a much larger range of heights than the other, you would know that the heights are more varied right off the bat. Another measure of variation is the IQR, which we know, I'm just going to put in parentheses here, is Q3 minus Q1, the interquartile range. That's another way to sort of gauge the variation that's happening with a particular data set. The third one, though, is, I think, the best one. It's my favorite one. It's something called standard deviation. And the thing with standard deviation is we're going to write down a definition for today. We'll actually look into how we calculate it tomorrow, but standard deviation is defined to be the average distance of each data point to the mean. So that's kind of a wordy definition. Basically, you look at how far each individual value is from that mean and average those distances. Here's a quick thing. Standard deviation can never be negative. So if you ever find a negative, that's a sign you've done something wrong. And the last thing for today that I want you to know is that the larger the standard deviation, the more spread out the data. And we'll get into analyzing the standard deviation. Ooh, might not be able to see that. Get into analyzing the standard deviation and calculating it tomorrow.